So, the bell work today. Jake has a jar full of sodium hydrogen carbonate, or what we call baking soda. What is the mass of 2.78 moles of baking soda? So, I'm going to go ahead and start out by taking 2.78 moles of, and then to save space, I'm going to write down here NaHCO3. What is the mass of the baking soda? So I'm in moles. I need to go into grams, or a mass. So I'm going to go ahead and calculate the molar mass of this compound. Sodium is 23. Hydrogen is 1, carbon 12, oxygen 16. There is just one sodium, there are just one hydrogen, there is just one carbon, and there's 3 oxygens. So 23 plus 1 plus 12 plus 48 gives us a value of exactly 84 grams per mole. So I'm going to plug that in. For every 1 mole of this compound, I'm going to have 84.0 grams of the same compound, NaHCO3. And the final value that I get for this mass is going to be 234 with proper sig figs, and that is grams of NaHCO3. So up to this point we have our 3 conversion factors, the first being representative particles, the second being molar mass, and then the third the molar volume of a gas. And so now what we're going to do is we're going to look at a few more things, this one today being percent composition. And percent composition is something that we've already done. We've seen the percent composition in the Beanium lab before. So what we're going to do is we're going to apply the same concept into our molecular mass calculations. So we're going to find the percent by mass of each element in the compound, and we're going to be dividing by whole. So the best thing you could do to remember that is to remember that it's going to be the part divided by the total. The part divided by the total. So if you want to write this on your page, I would write part over whole. And then to get a percentage, we need to take that number and multiply by 100. So if you want to write this in your notes, this will help you remember percent composition. So our first example says find the percent composition for a compound that is formed from 28 grams of iron and 8 grams of oxygen. So what we need to do is first find the total, because again it's part over whole. So I'm going to take 28 and I'm going to add it to 8. So 28.0 grams for iron and 8 grams for oxygen. When I add these values up, I'm going to get a value of 36.0 grams. And this is going to be our total amount. So to find the percent composition, I'm going to have a percentage for each element that I am looking at. So let's use a different color for iron. So to find the percent composition of iron, I'm going to take the part that was iron, 28 grams, and I'm going to divide it by the total, which is going to be 36 grams. To get a percentage, I'm going to have to multiply by 100. To do the same thing for oxygen, I'm going to have 8 grams, and then I'm going to divide it by the total, 36.0 grams, and then I'm going to multiply by 100 in order to get a percentage. So for this problem, I am going to get a value of 77.8%, and that is going to be for the element iron in this compound. So 77.8% of my compound is composed of iron, and I get a value of 22.2% for oxygen in this compound. So a good way to check yourself is if the percentages add up to 100, you've done it correctly. If they don't add up to 100, something has gone wrong. You need to go back and check your work. So why is Avogadro so rich? Because he is a multi-millionaire. And quickly moving on from the worst joke of all time, what is the percent composition of calcium acetate? So this is going to be the last example on this film. It's another percent composition, but in this case, I'm not given amounts or grams of the elements. So what I have to do is find them on my own. Well, what's nice is that we already know how to calculate molar mass, so we can use the same concept there to find our total or our whole amount of grams in this case. So calcium acetate, I need to find a total. I'm going to do that by finding the molecular weight or the molar mass of this compound. So first I need to write out my elements because I need to find the molar mass. So I'm going to have calcium, carbon, hydrogen, and oxygen. Calcium has a weight of 40.1. If I round to the nearest 0.1, 40.1. Carbon has a mass of 12.0, hydrogen 1.0, and oxygen 16.0. I multiply by the number of atoms of each element. Calcium, I have just 1. Carbon, I don't have just 2, because the 2 over here distributes to each element. So I actually have 4 carbons. 2 times 2 is 4. I'm going to have not 5 hydrogens. I multiply the 2, so I'm going to have 6 hydrogens. 2 times 3 is 6. And then on the last one here, oxygen, I'm going to have 4 oxygen molecules. So total, I'm going to add them all up. I get 40.1 for calcium, 48.0 for carbon, 6.0 for hydrogen, and 64.0 for oxygen. I get a total of 158.1, and that is grams per mole for this compound, calcium acetate. So this is going to be my total number. So to find the percent composition, I'm going to have to take the mass of each element that is represented in the compound and divide it by that total. So follow along. For calcium, I'm going to take this number, 40.1, and I'm going to divide it by my total, 158.1, and multiply by 100. Next, I'm going to take the mass that was carbon out of the molecule, which is 48.0, and I'm going to divide that also by the total. This is going to give me a percentage of carbon out of the entire mass of the compound, times 100 there to get a percentage. For hydrogen, hydrogen represented 6 grams. I'm going to divide that by 158, multiply by 100. And last but not least, down here, oxygen made up 64 grams out of the total, divided by the total, 158.1, and multiply by 100. So for calcium, the answer that I get is a percentage of 25.4%, and that is for calcium. So calcium makes up a quarter of this molecule's mass. For carbon, has a value of 30.4%, so about almost a third is carbon. Hydrogen composes 3.8%. Hydrogen is very small, it doesn't weigh very much, and so it's not going to take up a whole lot of the percentage here. And then finally, oxygen, 40.5% oxygen. And that is your percent. So, in the percent composition problems, you are going to have percentages that add up to right at 100, and it tells you the amount of, or the percentage of each element that's making up the mass, or the molar mass, or the molecular weight.